Most people found the Bohr diagrams pretty simple, but just in case you forgot, the first ring can hold 2, and it's like a small cup inside of a larger cup inside of a larger cup. So once you fill those 2, then they overflow into the next one. Boron has 5 electrons, so 2 go in the first ring, then the overflow goes into the next ring. Those overflow or remainder electrons are called valence electrons, and in this case we have 3. Sodium has 11 total, so 2 can fit in the first ring, 8 in the next, so 2 plus 8 is 10. That leaves 1 valence electron way out here on the outside. Fluorine has 9 electrons. It's number 9 on the periodic table. 2 electrons in the first ring, 7 in the next. It has 7 valence electrons. Isotopes, let's talk about those one more time. Isotopes are an atom of an element with the same number of protons and electrons as all the others. So for example, carbon is going to have the same number of protons and electrons no matter what isotope you're talking about, but there's going to be a different number of neutrons. And because of the different number of neutrons, we change the mass. Boron 10, boron 11 are examples. The 10 or the 11 afterwards is the mass number of that isotope. So boron 10 has a mass of 10, boron 11 has a mass of 11. This one's slightly heavier. Let's talk about numbers of valence electrons. Potassium has 1 valence electron. You can cheat and look at your periodic table where we drew it, and when we draw dot diagrams, we just put the K in a box for potassium, draw the 1 valence electron. Iodine has 7, it's in group 17. Carbon has 4 valence electrons, that's why it's able to make so many bonds. Helium has 2. Neon has 8. It is completely satisfied. It is in the noble gas family, so it doesn't like to bond with anything. And then nitrogen has 5. 1, 2, 3, 4, 5 valence electrons. Why do they want to lose or gain electrons? To become stable. They need to fill that outer ring of electrons. If you look back up here at our Bohr diagrams, they don't want to have a remainder. They want to be completely full. So fluorine's almost there. It has 7 valence electrons. If it had just one more, it would be completely satisfied. That allows them to be very, very stable. They either want that first ring to be full of 2. So if we had a really small element like hydrogen or helium, we just want 2 valence electrons in that first ring. But everybody else, we want to fill all of the outer ring, which holds 8. If it has 1 to 3 valence electrons, it's going to give those away, because it's easier to give away 3 than to go find 5. Because they're losing those electrons, and remember we compared electrons to your dorky little sibling, they become more positive because they got rid of all that negative stuff. If you have 5 to 7 valence electrons, you're going to want to go grab a few more to fill out your outer ring. They become negative charged because they're getting those negative electrons. Remember that electrons are negative, so if you get some, you're going to become more negative. If you give them away, you become less negative. So here's oxygen. Oxygen has 6 valence electrons. It needs 2 more, 1 here and 1 here, to be completely stable. Because it's going to be gaining negative charges, we give it an oxidation number of -2. It needs 2 electrons to be balanced. Magnesium has 2 valence electrons. It's just going to give those away, and by giving them away, it becomes more positive, so +2. Chlorine has 7. It needs to gain 1, so it has a -1 charge. Aluminum has 3 to give away, so losing 3 electrons makes you positively charged, so 3+. And arsenic has 5. 1, 2, 3, 4, 5. It needs to gain 3, so it has a -3 charge. This is important. Gaining electrons makes you more negative, losing electrons makes you more positive.